Good morning to all. Today I am continuing the discussion on the Newton ring. In the previous three lecture, I have discussed about the basics of Newton ring, about Newton ring assembly, an experimental set of Newton ring. Also, I have discussed about the theory of formation of Newton ring. In this, I am going to continue further discussion which is based on the expression of the diameter of rings, which has been established in last lecture. Now you see the diameter of the nth ring, bright and dark, are stated in equation 7, whereas the dn is directly equal to 2 square root of 2 bracket 2n plus minus 1 lambda r for the bright ring, and dn also equal to square root of 4n lambda r for the dark ring. This equation 7 states the condition for the bright ring and the dark ring. Now you observe in the equation 7, which has the dependence on the wavelength lambda and r and value of n. So in general, the diameter of nth ring, that is dn, is directly proportional to the wavelength of the light lambda, radius of curvature of plano-convex lens r, capital R, and the order of the fringe, that is n. So for the Newton ring assembly, the value of the wavelength is constant because the light is a monochromatic light, and radius of curvature is not changing in the experimental assembly. So therefore, value of capital R is also constant. Under this condition, the equation 7 suggests the dn is directly proportional to under root of 2n plus minus 1 for bright ring, and dn is also proportional to under root of n for the dark ring. That is equation 8. It is a very important equation for the further discussion. As the value of n increases, the diameter of the rings of both kind, bright and dark, are also increases. Now, in this pattern, as order increases, the diameter of the rings also increases. It also suggests certain important point. It also suggests the dn of the bright ring, diameter of the bright ring is directly proportional to the square root of the odd number, whereas the dn, diameter of the nth ring for the dark ring, is directly proportional to the square root of natural number. So I may conclude here the interference pattern in the Newton ring is an alternative bright and dark ring with increasing radius or the diameter as order increases. So it may also suggest certain important thing, that is the spacing between the successive Newton rings of the same kind. Especially for the bright ring, the diameter of the nth bright ring is given by as dn is equal to 2, sorry, this is also under root of 2, and this is under root of lambda. Now the dn is directly proportional to the square root of 2 bracket 2n plus minus 1 under root lambda r. Here, for the simplicity, I am considering the under root of 2 lambda r equal to capital K1. So the expression become 2 dn is equal to under root of 2n minus 1 K1. For the n plus 1th ring, the diameter is equal to under root of 2n plus 1 K1. Separation between means the difference between dn plus 1 and dn is given as, substituting the value of n in the above expression, we get the difference between the consecutive bright rings. Second and first bright ring has a difference of 0.731321 K1, and the third and second ring has the difference 0.5040 K1. As you see, the difference is decreasing as the value of n increases. Now the spacing between the third and fourth bright ring is equal to 0.4097 K. To observe these numerical value, it is continuously decreasing as order increases. So the spacing between the two successive bright rings decreases as order increases. In the same way, we may also see the similar information for the dark ring. So the spacing between the dark ring is given as, for the dark ring, the diameter of the nth dark ring is given as dn equal to under root of 4n lambda r, where the square root of 4 lambda r can be taken k2. So the expression become dn equals to under root of n k2. So n diameter of n plus 1th dark ring is equal to dn plus n plus 1 equals to under root of n plus 1 k2. This difference between these two consecutive rings, dn plus 1 minus dn is equal to under root of n plus 1 minus under root of n times k2. So now getting the difference between the two consecutive bright rings, first and second dark ring, sorry, is under root of 2 minus under root of 1 times of k2, which is equal to 0.4142 k2. And similarly, if we calculate and see, the difference is continuously decreasing, as it suggests that the spacing between the two successive dark ring also decreases as order increases. Now you can see the visible, this concept is visible. The spacing between the two successive dark ring also decreases as order increases. Dear student, Dear all, now I'm going to focus on the overlapping of the Newton ring at the peripheral. Look at that, the case for the dark ring. For a dark ring, the diameter of nth and n plus 1th dark ring are given. Dn is equal to under root of n k2, where k2 is square root of 4 times of lambda r, and dn plus 1 is equal to under root of n plus 1 times of k2. Taking the difference between them is bracket under root of n plus 1 minus under root of n bracket close k2. Under root of n to under root of n is taken out from this, so we have now n is a large value, so applying the binomial expansion, because 1 by n is a very small, therefore we have the dn is equal to k2 upon 2 times of under root n. Taking the limit on both sides, please see, taking the limit on the both side, limit tending to infinity, dn plus 1 minus dn equals to limit n tends to infinity k2 to under root n has. This is under root n. And therefore 1 by infinity tending to 0, therefore the difference between the two large value consecutive dark rings goes to 0. And it suggests that the dn plus 1 equals to dn. A very similar result can be found in case of the bright ring. Therefore, the all fringes of the higher order must overlap at the peripheral of the Newton ring pattern. Now, a question is there. The difference between the two consecutive fringes are continuously decreasing, and we know that the interference patterns are those patterns which are having equal widths and the equal intensity. But in case of Newton ring, if we see the spacing, or you can say width of the fringes, are continuously decreasing as order increases. So this is the fringe, or you can say Newton rings are continuously decreasing width fringe. So how do you say that this is a Newton ring, is a interference pattern? Dear all, for this we try to calculate the cross-section area of the each ring. So see the cross-section area of the Newton ring. Let the diameter of the n and n plus 1th dark ring is given as the dn under root of n k2, or rather we can say the squaring both sides, we get the dn square is equal to 4 n lambda r, as well as the dn plus 1 square is equal to 4 n plus 1 lambda r. To see the area of the nth and n plus 1th ring is given as the an is equal to pi dn square upon 4, and an plus 1 equal to pi dn plus 1 square by 4. So the difference between the area, this one, as you see, this is the area of nth ring, and this complete area is area of the n plus 1th ring. So we wish to calculate the difference between these two area. So we wish to have this area of this shaded region. To have this area of this shaded region, delta A is equal to an plus 1 minus an. That's come up pi by 4. That's come up pi by 4 lambda r. Because lambda is constant, r is constant, so the delta A is constant. Now we can say the cross section area of the any ring is also constant, and it is independent of the order of fringe. On this basis, we can say the interference pattern, Newton ring is an interference pattern. Thank you to all. If you have any query, please write me on my email address drrkp70@gmail.com. If you have any doubt, please write me. And I advise you to all, please go through the some standard book. Thank you once again to all.